Today we're going to talk about pediatric advanced life support, specifically the drips that we'll be calculating in it. We're going to start off with epinephrine. It's an adrenergic agonist. We're primarily going to be playing on the alpha sites, causing vasoconstriction, which is what we want. We will also get some beta effect for some inotropic and chronotropic effects. We want that increased vasoconstriction. That's going to directly lead to an increase in mean arterial pressure, which is the ultimate goal so that we can reperfuse our organs. Keep in mind your overall dose is going to be 0.1 to 1 micrograms per kilogram per minute. With that being said, we want to make sure that we have the right concentration. We're going to take 1 milligram of epi in 1 ml, and we know that 1 milligram converts into 1,000 micrograms. So the desired concentration that we're going to be looking for is 1 milligram in 100 mLs, which will convert down to 1,000 mics in 100 ml, which converts down to 10 micrograms in 1 ml. So that's the concentration we're going to be using for our drips. All right, next I want to talk about how to set up your drip equation. So this is pretty vital. You want to make sure you stick to the same format every time. We're going to be comparing our drip set to our concentration to the dose over time. All right, so now we want to make sure that we cancel out our units appropriately. We're canceling out milliliters and micrograms, and eventually zeros if we can. Then we're going to multiply the top, multiply the bottom, and then we'll simplify for our drops per minute. So we're going to use this example here. We're going to have a 4-year-old patient that weighs 50 pounds, and the order is 1 microgram per kilogram of epi. All right, so we're going to have our 60 drops set. We have our concentration of 1 ml over 10 micrograms, and now our dose, 1 mic per kg. So let's simplify 50 pounds down to kilograms. Well, you can do the classic divide by 2.2 and get 22.7, or you can divide by 2 and subtract 10%, which gives you 22.5. Either way, we're going to go ahead and round up to 23 kgs. So we're going to multiply 23 by 1 microgram, which obviously gives us 23 micrograms. And we're going to put that over 1 minute. All right, when we do so, then we simplify down to 60 drops times 23 over 10 minutes. That's going to give us 1380 drips in 10 minutes, and then we simplify further, crossing out some zeros, and we have 138 drops over a minute. Now, if you want to calculate how many drops per second that will be, just go ahead and divide 138 by 60, and you will have 2.3 drops per second. So that way it's a little more real-world, realistic way of using it on a truck. And that was how to calculate the 1 mic per kg dose. Let's say that you want to start low and you want to do a 0.5 micrograms per kilogram per minute. Well, if that's what you want to do, then just go ahead and simply divide your final answer by 2. So you're literally cutting your drops per minute in half, and that's going to give you the correct drip rate for 0.5 mics per kg, which in this case is going to be 69 drops per minute. All right, next we're going to talk about dopamine. Our dose for dopamine is going to be 10 to 20 micrograms per kilogram per minute. A little background on dopamine is really cool. It's a very dose-specific medication. So from 5 to 10 mics per kg per minute, you have strong beta effects, the strong beta adrenergic effects, including the increased inotropic and chronotropic effects. From 10 to 20, however, you get strong alpha effects, and that's what we're wanting here. Again, we're trying to vasoconstrict. The more vasoconstriction we have, the higher the mean arterial pressure may rise, which again is ultimately what we want because we're trying to reperfuse the brain and vital organs. All right, so for our dopamine calculation, we're going to have a very similar patient as last time. We're going to have a 4-year-old patient that weighs 50 pounds. And we're going to go ahead and we're going to do the 10 micrograms per kilogram per minute dose. All right, so again, we're converting our 50 pounds we're divided by 2, subtracting 10%. We'll just round up to 23 kgs. And so we're going to multiply 10 by 23 kgs and get 230 mics. So using our equation that we established earlier and our known concentration of dopamine, we'll have 60 drops in 1 ml. 1 ml over 1600 mics, and then 230 mics over 1 minute. So now we can cross out some zeros as well. Just remember, our concentration 1600 can only give away 1 zero at a time. So that gives us 8.6 drops per minute. Now, if you want to get the result for a 20 mic per kg dose, then simply just multiply 8.6 drops per minute by 2, which is going to result in 17.2. All right, Levophed. Let's talk about Levophed. It is a very potent vasoconstrictor, which is good. We want that increased mean arterial pressure. It has a high affinity for alpha receptor sites. So that's going to be that why we result in vasoconstriction. Dosing range for Levophed is going to be 0.1 to 2 micrograms per kg per minute. And typically it's packaged in 4 milligrams and 250 mLs. So we'll convert that down to 4,000 over 250 mLs. Cross out some zeros, do some division down to 16 mics per ml, and we're going to plug that into our equation. And looky there again, we're going to have a 4-year-old male who weighs 50 pounds, and our order this time is going to be 1 microgram per kg. So we're going to go ahead and start using little blocks of information here. We have 1 mic per kg. Our patient weighs 23 kgs. Our concentration again is 16 mics per ml, and we're using a 60 drop per ml set. So now let's go ahead and do our work. 60 drops in 1 ml, 1 ml over 16 mics, and we're going to go ahead and do our dosage here. 1 mic times 23 kgs is 23 micrograms. Over 1 minute, cross out our units. And that's going to bring us down to 60 times 23, and that's going to equal 1380 drops. And then we're doing 16 minutes. So 1380 divided by 16 is 86.25 drops per minute. All right. And if we want to figure out how many drops per second, we can just divide that by 60, and we'll have 1.5 drops for every second. Let's talk about Dobutamine. Dobutamine is also an adrenergic agonist. Primarily, it's going to be hitting the beta receptor site, so that's why we consider it a first-line inotropic medication. We get primarily inotropic and chronotropic stimulation. A way of looking at Dobutamine is that it acts as a chemical balloon pump. You're going to get increased cardiac output along with a little bit of mild vasodilation. So we're reducing afterload. The typical concentration here is going to be 500 milligrams and 250 mLs, which again we convert down to 500,000 mics and 250 mLs, which will convert even further down to 2,000 micrograms per 1 ml. So this is what we're going to be plugging into our equation here. We're going to use the 2,000 mics as our concentration. And again, 4-year-old male, just for the simplicity, 50 pounds. And we're going to use the order of 10 mics per kg per minute. So we're going to go ahead and set up our equation and our little brackets of information. We know our order is going to be 10 mics per kg. 50 pounds converts down to 23 kilograms. Our concentration again is going to be 2,000 micrograms per ml. And our dose, we're going to go ahead and multiply 23 by 10 for 230 mics. We're going to plug that in as appropriate. And we're using a 60 drop set. All right, so we're filling out our equation. 60 drops, 1 ml. We have 1 ml with 2,000 micrograms. 230 mics over 1 minute. So let's go ahead and cross out our units here. All right, we can take away some zeros as well. Concentration can only give away 1 zero at a time. Don't forget that. All right, so 6 times 23 over 20. It's going to be 6.9 drops per minute. And now if we wanted to go ahead and do the 20 mics per kg, again, we're going to multiply 6.9 drops by 2 and get 13.8 drops per minute. And that is for the 20 micrograms. So let's talk about amiodarone for a second. We're going to be using the amiodarone in this situation for refractory wide complex tachycardias, VTAC, or potentially VFib following cardioversion in pediatrics. So our dose is going to be 5 mg per kg over 20 minutes. Technically it's 20 to 60, but just for the sake of simplicity, we'll do it over 20 minutes. And typically that may be a comparable transport time. So using our typical patient, again, 4-year-old, 50-pound, and our dose of 5 mg per kg. And amiodarone is typically concentrated in 50 milligrams per ml. Again, the patient's weight converts down to 23 kilograms. And our dose, we're going to do 5 times 23. That's going to come out equaling 115. We're using a 60 drop set, and we're doing this over 20 minutes. All right, so we can go ahead and fill out our equation. So 60 drops and 1 ml, 1 ml with 50 milligrams, and 115 milligrams over 20 minutes. So now we're going to go ahead and cross out our units and do a little bit of math. All right, so 60 times 115 is 6,900 divided by 1,000. We can go ahead and cross out some zeros, simplify a little bit. And then 69 divided by 10, we just move our decimal over and we have 6.9 drops per minute. Thank you guys for tuning in. Go ahead and send us an email if you have any questions. And log on to www.laniertech.edu for more information on programs that we offer.